All right, well, this equation that brings something different to the table entirely. It's a trinomial like we're used to, but what we're not used to is this x cubed at the beginning. We're used to seeing x squared. So since this starts with x cubed, even it's not a quadratic equation, it's a polynomial. It's a trinomial, but not a quadratic equation. Because of that x cubed term. But when we look at this for just a moment longer, we see that every single one of these terms has an x in it, which means x is a factor of everything, so we can factor it out as a GCF. So when we factor out that x, we see that things get much friendlier looking in there. And furthermore, but in this parentheses, we are going to have to do some factoring by grouping. So let's get down to that. So don't forget to bring this x down. Even though we factored out, we are not done with it. And I'm going to change those parentheses into brackets because I'm going to be putting some more parentheses inside here. So the next thing we need to do is to split up our middle term. And to do that, recall that we need to look for two numbers who have a product of 6 and 1, or 6. So we need them to have a product of 6. So if my two missing numbers are a and b, they multiply together to 6, and they add up to -5. So from this, we know that if the two numbers have a positive product, in other words, this positive 6 here, that they both must have the same sign. And since their sum is negative, they add up to this -5, they must both be negative. So I'm going to list my negative pairs of factors of positive 6. So -1 times -6 is absolutely positive 6, but the sum is -7. So they won't do. So my next pair of factors is -2 and -3. And they also multiply to positive 6, and furthermore, they add to -5. So it looks like I've got my pair here. So I'm going to continue filling in this parentheses here and split up that -5 into -2 and -3. So I have 6x squared minus 2x minus 3x plus 1. And then I'll put this bracket over here, and this whole thing is equal to 0. So now I'm going to group them. That's why I did the bracket. And I'm going to look for a GCF inside of each of these pairs of parentheses. So bring down that x again. I see that 6x squared and -2x share a common factor of 2x. So I'll take that 2x out, and that will leave me with a 3x and a -1. I see that 3x in the next parentheses, -3x and 1, are mutually prime. They don't have a greatest common factor. But we can always take a 1 out of any two numbers, so when we have nothing else to do, we'll take out that 1. And furthermore, since this is a -3, I'll actually take out a -1. So I'm going to take a -1 out of this second parentheses. That gives me the other 3x minus 1 that I need. And now I am going to take out that 3x minus 1. And that will leave me with 2x minus 1 in the other parentheses. So this looks a lot like what we've been doing, but what's different is that x that's out in front there. I've been bringing it down without really mentioning it, but it's important to have it still be there. So I'm going to start on a new screen here to give us room to do the rest of this. So I brought up what was at the bottom up to the top here. We have x times 2x minus 1 times 3x minus 1 equals 0. So what's different here, where this x cubed, this is going to come back and make things different again, is that we now have three things, three factors multiplying together to give us 0. So the 0 property says that if any two, recall over here on the left, that if any two numbers multiply to 0, then either a equals 0 or b equals 0. You can only get a 0 if one of the things is 0. Well, that actually works for any number of factors. So if a times b times c equals 0, then any one of those three things could be 0. So a equals 0, or b equals 0, or c equals 0. Any one of those things could be the case, or certainly if all three of them or any two of them were 0, it would work also. So that is what's going to come into play in this situation. So I have three possibilities. I have the possibility that x itself is equal to 0. I have the possibility that 2x minus 1 is equal to 0, or that 3x minus 1 is equal to 0. Well, the nice thing is this left-hand solution is already done. There's no more solving to do. One of the possible values of x is 0. And I just have to do a little bit more work on these other two to figure out what my other values of x are. I see that x also could be 1/2. And over on the right side of the screen here, I see that x also could be 1/3. So three solutions to this polynomial equation.